Today we are talking about the criticism of Mendeleev periodic table. This is also called defects of Mendeleev periodic table. Let's have some important defects of periodic table which were criticized when Mendeleev presented this table. First, anomalous position of hydrogen. Hydrogen position is not clear because hydrogen was placed with alkali metals in group 1, but it is non-metal and its property is similar to the halogen of group 7. Why don't we see the old periodic table? Look at this. Hydrogen was placed with alkali metals like lithium, sodium, potassium, rubidium, cesium, francium, etc. They are metal. They react very easily and very fast by donating one electron to other. But hydrogen is non-metal, not like lithium, sodium, potassium. It is similar to fluorine, chlorine, bromine, iodine, etc. Why hydrogen is not taken in group 7? Why it is taken in group 1? This was one of the great criticisms of that time. Next, anomalous pair of elements. Some of the pair of element its position in the periodic table was criticized. Some elements having higher atomic weight precede the elements with lower atomic weight. For example, argon, its atomic weight is 39.9 and it precedes potassium having atomic weight 39.1. Why argon is not behind the potassium? It was criticized. And similarly, cobalt atomic weight 58.9 precedes nickel atomic weight 58.7. Looking at the atomic weight, if elements were arranged in the increasing order of atomic weight, then certainly cobalt should go back to nickel. But cobalt was placed before nickel and it was criticism. Look at the periodic table again. Argon's atomic weight is 39.9 and atomic weight of this potassium is 39.1. And why argon is taken before potassium? Why argon precedes potassium? It was questioned at that time. In the same way, cobalt, its atomic weight is 58.9 and nickel, its atomic weight is 58.7. Why cobalt is placed before nickel? It was criticized like this. The reason is very simple. Argon is similar to neon, krypton, xenon, etc. That's why argon should take this position. In the same way, potassium, it is similar to sodium, rubidium, etc. That's why potassium should be placed in this position. In the same way, cobalt is similar to rhodium and iridium. That's why cobalt should be taken in this position. And nickel is similar to palladium and platinum, so nickel should take this position, but it was not matching with the atomic weight. Increasing order of atomic weight was violated and it was the violation of the Mendeleev periodic law. That's why it was criticized. Okay, now next. If periodic table was made according to the increasing order of atomic weight, then isotopes should also have position in the periodic table. Do you know what is isotope? Elements having same atomic number but different atomic weight is called isotope. Just for example, hydrogen has got 3 different isotopes: protium, deuterium, tritium. All of them have same atomic number, that is 1. But protium has got only 1 proton, that's why its atomic weight is 1. Deuterium has got 1 proton and 1 neutron, its atomic weight is 2. And tritium has got 1 proton and 2 neutron, that's why its atomic weight is 3. So look at the periodic table. This hydrogen should be protium, and if this periodic table is made in the increasing order of atomic weight of the element, then not only the protium, deuterium should be at this position and tritium should be at this position, but deuterium and tritium were not taken in the periodic table. And other isotopes were also not taken in the periodic table and it was criticized a lot. Now another criticism. Dissimilar elements in the same group but similar elements in different group. Some dissimilar elements were placed together but some similar elements were placed in different group. We can take example, copper, silver, gold, etc. are placed in group 1 with alkali metals like lithium, sodium, potassium, etc. But similar elements like copper and mercury were placed in different groups, that is group 1 and group 2 respectively. Let's have the periodic table and try to understand this. This copper, silver, gold, they are placed along with the alkali metal like lithium, sodium, potassium. They are highly reactive, but copper, silver, gold, they are very less reactive metal. Dissimilar elements were placed together in group 1. In the same way, copper and mercury, they are similar, but they are placed in different group, and this was also criticized. Okay, now another criticism: position of lanthanides and actinides. Actually, there was no any place for lanthanides and actinides in old periodic table, in Mendeleev periodic table. Let's have a look on the periodic table. There is no any position for lanthanides and actinides. Lanthanum is here and asterisk mark is given here, and lanthanides are not taken, and actinium is here and a double asterisk mark is here, but actinides are not taken in the periodic table. But in modern periodic table, the lanthanides and actinides are placed at the bottom side, not in the main periodic table, at the bottom side in a definite position. So the old periodic table was criticized. Mendeleev periodic table was criticized. Okay, another position of elements of group 8. Actually, position of elements of group 8 was not clear because 9 elements of group 8 were placed in the form of triad without any justification. Look at this. I want to show the periodic table. Look at this. Iron, cobalt, nickel were taken in place of one element. In the same way, there are other triad also. These triads are placed in this position without any justification. Why 3 elements are placed in place of one element? It was not justified. No any argument, no any comment, and that's why it was also criticized. Okay, now I want to stop. These were the major criticism or defect of old Mendeleev periodic table. Okay, now I want to stop. We'll meet in another class.